Hello, welcome to IPDay's Wednesday webinar. Excited to be with you here today to talk about essential algebra skills. We're going to look today at the first and arguably the most important algebra skill you can work with your students on, and that is the skill of substitution. My name is Kate Redman. I am an IPDay subject matter expert. This is my second year working with IPDay, and it has been a joy. I'm also the founder and CEO of Light and Salt Learning. And so what I do in that is I work with struggling students, specifically students with learning disabilities and other significant learning struggles, and teach them mostly math, and especially algebra. Some things to remember today, just some housekeeping. Please, if you have any questions, you can type it into the Q&A or you can type it into the chat. We're expecting a large audience today. A lot of people signed up. So if I don't get to your questions, we have the ability to look back at them and make sure they do get answered. So yeah, just go ahead and ask them if you have them. We'll do our best to get to them in the webinar, but if not, certainly we can let you know afterwards. Your microphones are going to be muted. Thank goodness we don't need 50 of you dogs in the background. You're going to be in listen only mode. And we are going to record today's session. And you'll be able to go onto the IPDay's website in 48 hours and anybody can access the recording of our Wednesday webinars. All right, let's get started. So today, what are we going to be looking at? I'll introduce you to the concept of substitution. What I'm talking about, a lot of times when people use the word substitution, they're talking about a single solitary lesson. I'm going to use it in a much broader sense than that. So we'll look at that. We're going to see how substitution has really been used all along in mathematics from basically the time you started adding 1 plus 1. And then we're going to look at how it shows up now in this essential new skill in the world of algebra. There's a lot of different ways we see substitution and it gets utilized. And then finally, we will look at some examples across the curriculum and across the levels of different examples of substitution, kind of angles you can attack it from. And hello to everyone who said hello to me in the chat. All right. Oh, tech issues. Sorry. So let's introduce the idea of substitution. All right. We are going to, if you've seen, this is actually the first of a three-part webinar that will look at the three essential skills. But the three biggest skills in the world of algebra are this first one, what we're going to look at today, substitution. Then after that, the act of simplification, which again is something we've been doing since the beginning of math. 1 plus 1 equals 2 is an act of simplification that involves substitution. But obviously we need to be able to do it in the world of algebra. And then solving linear equations and inequalities. And that's pretty much the summation of most of the basic math that's on the GED and most of what our students need for college. Now, you could also include symbolic fluency, the language of algebra, basically in that, but I don't teach that like a separate skill. I think it's really important that whether you're doing substitution, simplification, solving equations, you're constantly reinforcing the language of math. We treat it like a language that we're speaking and reading all the time. And so that's why I didn't identify it as its own skill. All right, so what am I saying when I say substitution? Again, I'm not talking a specific lesson. I am literally talking about the act of trading one expression for another equivalent expression. And the word expression in mathematics is super generic, you guys. An expression is just a mathematical phrase. So it could be a single number, like 4, or a single variable, like x. It could be that simple, but it could also be more complex, like 3x minus 2y is an expression. So anytime you take an expression or a piece of an expression, trade it out for something it's equal to, you have done an act of substitution. It's a trade. All right. So now knowing that, I have a question and you can answer in the chat and I get to slow down and read the chat. Hey, okay. Which of the following skills do you think utilizes substitution? And here's a list of a bunch of GED skills that our students need. Evaluating expressions, simplifying expressions, using formulas. So which one of these do you see substitution coming in? The act of trading out one equal thing for another. Hey, do I need a D? All of the above? I see a whole lot of all. All of them, all of them, all of them, all. All. Anybody care to explain themselves? Paul, is that D all of the above? I bet it is. I'll give it a second more so you can read through the list. Some of you guys jump straight to all. Oh, that's all I got? All of them, all of them? All right, okay. I would agree with you. In one way or another, just about every one of these skills has some idea of trading out one thing for an equivalent thing. In fact, that is the basics of mathematics. A mathematical argument starts with something we know to be true or we assume to be true, and then you just keep trading things that are equivalent. So let's talk though about when we start trading in the world of algebra. So the first thing is a common student misconception about substitution is instead of doing substitution, the trade, they do insertion. Beginners will insert an equivalent expression without removing the original expression. So here's what I mean. Like, for example, we ask them to evaluate 2x plus 1 for x equals 7. And I see weird things where students put in numbers like 7, but leave in the x. This is a common issue for students, especially with symbolic processing order issues, or just real newbies, anybody who's lost in the language of algebra. So you might see them leaving things behind instead of doing a full trade. So what is my solution for that? Well, the first thing I always do is I stress the meaning of the English word with my students, and I talk about what does it mean to substitute as far as English is concerned. And I usually talk about substitute teachers because I'm like, if I had a substitute and I brought them in here today, would I still be here? And of course, the answer is no. I would be skedaddled. I would be out of there. And students are certainly aware of that. And so I kind of come at it from that angle that you know what this word means in English. We can understand it in math class as well. But another great method, especially for students with any kind of issue with symbols, is to use boxes or color coding to help students visualize the change. So again, if I was asked to evaluate, say, 2x plus 1 for x equals 7, and I was demoing this on the board, I would say, okay, we're going to substitute out, and I might box x, replace it with 7. Of course, I would discuss the reason why I need parentheses there, that 2 and x were shoved together, so they were multiplying. And then I would just have them drop down everything that's outside of the box. And so by giving that visual clue, that works. Some students prefer colors. So rather than using a box, I might change out the color whenever I go to make a trade. And this is my favorite method because it's neater and you can very quickly skim with your eyes and see a change, which students really, really struggle with seeing the difference from line to line of mathematical text. All right. Another issue that I have with substitution, a common student issue is, but which one is right? So a place that you'll often hear this is actually for a final answer. Students will tell me, oh, Miss, I got the answer 1.5, and the answer key says it's 3/2. Why'd I get this wrong? So this is a common issue where they're asking me why'd I get this wrong, and they're not understanding that it's a simple swap, it's a simple substitution. Two things are equivalent to each other. We're always allowed to trade them out in math. There's not a time when one of these is a wrong answer. Now, there's a time when maybe I didn't request that form of a number, but still neither one would ever be wrong. And so it's really important to clear up that misconception with students. So there's no such thing as one equivalent expression being right and another wrong, unless, of course, I specifically asked for something. You should be able at any time in the world of mathematics to trade out two things that are equal. So yes, we're going to stress that no equivalent expression is more correct than another. My favorite thing to say, I'm so bad to my students sometimes. They'll say, but which one is right? And I say, uh-huh. They're both right. Of course, some may be more useful in one situation than another. We can recognize that. Okay, another common student mistake is an incomplete substitution. Even experienced students will leave out part of an expression that they're substituting in, or even part of the original expression. So usually we do see it with negative signs or minus signs, but you're really going to see it with any sign or symbol that students have struggles remembering or understanding. Whenever you have a conceptual understanding of something that's lacking, that's weak, you're going to see more transcription errors, more dropped symbols. And so times you'll especially see it as negatives, exponents. Yeah, let's see. Oh man, radicals that have the index in the little check mark there, like the cube root. That cube root. Oh man, will it ever get dropped? And oh, fractions. Great example, area of a triangle formula, A equals 1/2 B times H. Very simple formula that even a beginning level student can accomplish. And yet what a common issue is, they'll go to do the substitution like, oh, the base is 5 and the height is 8, and the 1/2 will drop out. And so that's not really so much of an issue with the actual substitution itself, but still, they should be able to um, see that exact trade of every symbol either is still there or gets replaced. Okay. So solutions for that, we need to stress that every symbol from the original expression and the expression they are trading for must be accounted for. And again, we can use boxes or color coding to help students visualize the change. But I think actually I should have written this. The most important thing, I think, is actually alignment. Really do a good job of making sure students are almost a little anal with their lining up. And if you have a student who's super struggling with it, do it with graph paper. Literally, graph paper can make a really big difference for students who drop symbols. And so we can make sure that every symbol from above is either replaced or copied. And I have that beautiful lineup, making sure my 1/2 lines with my 1/2, my equals with my equals, my base with my base, and my height with my height. Super crucial. That lovely lineup can help a lot of struggling students. And I'll say to my students, if you get lost in the world of algebra, you're supposed to be able to just look up. Where do you find your answers? Just like in life, you just look up. All right. And so if they're really used to and good at making that alignment there, they're going to have less struggles with substitution, and not only substitution, simplification as well. Another common one is leaving out needed parentheses. Parentheses are often needed with substitution, and students will drop them. So, and this happens at all levels where they'll plug in complex expressions that should have been grouped in parentheses and were not. Here's the most famous example when we're plugging negative numbers into exponential expressions. So if I ask a student to evaluate x to the 4th power when x equals 1, almost every student and half the teachers I've met will just write this. -1 to the 4th power. Yeah, so even if you plug in -1 to the 4th power in your calculator, you'll tell me it's a liar that you get a wrong answer, because you will get -1. Why? It's the order of operations, you guys. The order of operations say exponents happen before multiplication. Exponents happen before. You say there's no multiplication there. There is. Negation, negating a number, is an act of multiplication, which means in this particular expression, it's only 1 that's being raised to the 4th power. 1. And then it's getting negated. Negating happens after exponents, because negating is multiplication. So what does a student need to do if they want that entire -1 to get raised to the 4th power, like this expression says? They would need to use parentheses. -1 goes inside the parentheses. The 4 comes outside of it. And by the way, this is the most common student error. So many students make it. I can't tell you how many videos I have on it. And if you could just clear up this one issue with your students, you're going to find that they score so much higher on their GED. So, and the GED knows, by the way, that this is a common error. So almost every substitution problem where it's just straight evaluation on the GED has negative numbers being plugged into exponents. But anyway, if you take -1 to the fourth power, what are you saying now? You're saying that you want to take all of -1 and raise it to the fourth power. And of course, we know a negative times a negative is a positive. Same thing again. And so I would end up with +1. So those two expressions are different. So they need to know to use parentheses. Okay. All right. So I will often tell my students that exponents are weak. They only work on the number they're directly attached to. That does not include the sign. Of course, I do explain it based on that order of operations, but as we continue and people continue to make that mistake, that's just my very simple explanation. We have got weak little exponents. And this one is important. Check all answers involving negatives using the store function in your calculator. Did you guys know the GED calculator will do substitution? Not just the simplification of crunching the numbers afterwards, but the actual substitution. I'll tell you, I did not know this for years. It was another teacher who taught me this, and it was one of the happiest days ever when I figured it out. So I am going to show you guys real quick. Okay, hopefully everybody can see my calculator here. But if I wanted to do -1 to the fourth power, I can store that value. Here, let me write down my problem first. Evaluate x to the fourth power for x equals -1. Awesome. First step is to store any known values in your calculator. So we know that x is equal to -1. To tell your calculator the same thing, you type in the number first, -1. Then you press the store function. It's right there on the left of 1, STO with an arrow on it. And now the button right above it is your variable button. You can store -1 as x. Press enter to communicate that to your calculator. And now your student can just type in x to the fourth power, and it evaluates that for them. And this function is really nice because we can do some complex problems like this. Like even if I had multivariables, let's do evaluate -2x, y, z squared for x equals -1, y equals -2, and z equals -3. This is a nightmare for students. So many chances to drop exponents, so many chances to drop negatives if they do the substitution by hand, easily accomplished in the calculator. So again, I'll store -1 and store it for x. Type in -2, and I can store that for, if I want y, I use the same button, I just hit it twice, and there you go, stored it for y. -3, store as z. And now I can type in the entire expression just the way I see it. -2x, arrow over to be able to type the next variable, y, arrow over again. I can type z, square it. Wow, wasn't that nice? Just teaching that skill right there gave your student 5 to 6 problems they can do with the calculator, between the geometry that's on the GED and the algebra that's on the GED. And hey, half your students just passed, right? How many of your students are stuck in the 140 to 145 range? All right. Okay, that's my argument for the calculator. Okay, give me just 1 second, you guys. Okay, lovely. All right. So substitution, like I said, yeah, we're looking at some complex examples when we have the x and the y's, but it's really not a new skill. It is a basic math skill. Anytime we said that you trade equivalent expressions, it's substitution. And so really just the act of saying 1 + 1 = 2 is an act of substitution in and of itself. Yes. Did we simplify? We added 1 and 1. Yes. But we traded out something, 1 + 1, for something else that's equal to. And you're going to notice that whenever I simplify down. And even when my PowerPoint was getting edited, I got asked, shouldn't we put the equal sign on the right-hand side? Shouldn't we write that like this, 1 + 1 = 2? And I said, absolutely not. If I could convince elementary school teachers of any one thing, it would be to convince them to stop simplifying across equal signs and to simplify underneath. Why? Because starting in algebra, that is the way we work. We simplify down. Whenever we're jumping an equal sign, we're solving, we're using inverses. And so if your student is used to the equal sign meaning, and here's the answer on the right-hand side, they are going to really struggle when they suddenly have to now simplify down and solve across. And so I like that good habit right from the start. But anyway, that's why I wrote it funky if it's upsetting you. Can somebody get the third grade teachers on my side? I don't know. They aren't listening to me. So some other common substitutions in arithmetic, however, they trading expressions or parts of expressions for simpler expressions. I'll give you an example. When you're doing what you guys call an order of operations problem, not really an order of operations problem, you guys, this is an expression to simplify. But if I were doing that, I would take a part of the expression 5 plus 3 and replace it, trade it out for something simpler, 8. And then we see the rest of the expression remaining the same. And then same thing with each step as we work through that order of operations. We're just doing a substitution, substituting a simpler expression for a more complex one. Conversions to trade equivalent values. So we already talked about that. But anytime you convert a percent to a decimal or a decimal to a fraction, or a number in scientific notation to a number in standard notation, you are committing an act of substitution, and really looking at it through that lens, like I said, can help students who struggle with which one's the right answer. Raising and reducing the terms of a fraction. I think it's the National Council of Teachers of Mathematics who doesn't like the term reducing fractions. They actually say it's important to say reducing to lowest terms. Like you can't just say reducing by itself, because we're not really reducing the fraction. We're not really making it any smaller. We're just making it a simpler version, but we're still trading, right? If we say 6/8 is equal to or is the same as, oh, I should have written it up and down like I wanted to, 3/4. All I'm doing is trading out two equivalent values, right? One is in lower terms than the other, but they are still equivalent, always legal. Okay, now obviously substitution gets a little more complex when we hit the world of algebra, but it is essential. Like I said, I was working with a student on this literally yesterday, and I said, oh, this is such good practice because I'm talking about this to a bunch of teachers tomorrow. But I was telling her substitution is literally the biggest skill in algebra. We use it repeatedly over and over and over and over again. So if you can master this, you might not even need any more tutoring from me, because right here we just hit 5 or 6 GED style problems. So that being said, that means that you don't have to teach the same lesson every time you introduce substitution. So I don't know how you guys teach, but I had the typical GED style classroom in that I had levels 1 through 6 in the same classroom, and everybody is at very different levels because I had a big spread out county that I had to tend to all the needs with a low population. And they could be working on any subject. They weren't even necessarily working on math. And here I am trying to teach a lesson that applies to everybody. So can we do that? Yes, we can teach substitution in ways that apply to everybody because there's so many natural places to introduce it. So one great place we already talked about is when we're doing that order of operations. And let me bust out a little more complex example. 5 times the quantity of 9 minus 5 cubes. Let's look at that. So again, if you're doing this, do not let students do the weird thing where they like go 9 minus 5 is 4, and then 4 cubed is 64, and then 4 times 5, it's, what is that? That You're setting them up for failure if they write that way. And now we're going to work into the world of algebra where we need to see those beautiful equivalent expressions every time we go down. That's what substitution is based on, the fact that each line is exactly equal to the line before it. And so we can develop that wonderful good habit of substitution right from the start. And like I said, I think my favorite way is with those colors. So I'm going to just demo for you what I would do here. And we could even use boxes and colors in combination. But of course, 9 minus 5 is 4. And now I have that visual that they can see I substituted 9 minus 5 for 4. I traded that out for a simpler form of the same expression. And now the rest of the expression will remain the same. I haven't done anything to change it. And then same thing, I can continue that way, boxing the next part of the expression, replacing it. And as we see that beautiful track of that substitution down the side of the paper, oh, what is that, you guys? 320? 320, I think. But the idea is that they have that lovely visual of how it's just a substitution. I'm just trading out this, what's in this box for this new color expression. Okay, it's really challenging when you're doing a webinar and everybody's silent. I don't know if I'm going too fast or too slow. I hope I'm going at a good speed for you guys. I know sometimes I get too mathy and I just go off. Oh, good. Great, guys. Thank you. So next place that we could definitely introduce substitution is identifying undefined expressions. So this is a really common one in the first 5 questions of the GED that the students have to do without a calculator. So this is a natural time to use substitution. One example might be what values of the variable would make the expression maybe the square root of 2x minus 1 undefined. And these questions are always multiple choice questions. So you might have like 1, 3, -4, and I don't know, 4. This is a natural time to teach it because they can just plug it in and see if we get something undefined. And the other one that you'll see with this is with fractions. You know, when we have a 0 on the bottom of a fraction, it becomes undefined. Or this particular example, a square root, when you have a square root of a negative, it becomes undefined. So this is a great time to practice substitution because your students can just plug into it, work it out, see if it comes undefined, and they're repeatedly plugging in over and over again. And so they're getting great substitution practice while working on this non-calculator section of the GED. Obviously, when we are introducing one-step equations, that's a great time, and that's beginning level algebra, right? Usually the first algebra lesson you teach is how to solve one-step equations. So let's say your students solve it and they get to this solution of x equals 4. Do you then have your students come back in to the equation and check their answer? Because if they do, that's an act of substitution. We plug in that 4 and see if 2 times 4 really does become 8. And so that's a really natural time to introduce substitution long before we're even evaluating expressions. Or you can start with, and these kinds of questions are on the GED, although they're a little more complex than one-step problems, but something like, is 5 a solution to 3x equals 12? Now, obviously, you guys can look at that and see it's not, but you could have a student plug in and do substitution to determine if that is true. And this, like I said, this style of problem is on the GED, and you see it in simpler examples like equations with a few steps, but you can even use it in more complex examples like solving quadratics. We have multiple choice answers, so we can guess and check. Evaluating expressions obviously is a natural one. I think this is where most people introduce it, where I do when I'm doing a algebra semester. So I already showed you guys one like that, but that's where it says something like evaluate the expression 2x minus 1 for x equals 7. Other times you can introduce it. It doesn't have to be in the context of algebra. If you're introducing area and perimeter formulas, let's say you're focused this semester not on algebra, but you're focused on um, geometry, you can still really get them good at the algebra skill of substitution when you're doing those area and perimeter formulas. We already talked about it, for example, with find the area of a triangle. But now it's lovely in geometry because you're combining three key skills when you deal with it. We're going to have to do substitution if I find the area of the triangle. I'm going to have to interpret that word problem to go find the base and the height and what they're asking me for to choose the appropriate formula. And then, of course, from there, I need to be able to choose algebraically if I'm simplifying or solving. So you're really bringing together every skill when you do formula sheet-based geometry with your students. You can teach it in the context of science. So you have a student who's like, Miss, I already passed math. And you say, maybe that doesn't happen a lot in your classroom. It actually happens in my classroom. People pass math first, and I get students who are stuck on the other subjects. And so I can have them doing the science formulas. I just had a student report today that they saw a bunch of physics formulas on their science test. They don't have to memorize the physics formulas, but they do have to be able to apply them. Again, that's using substitution. Another great one, maybe you're doing a semester where you're focused on word problems. You're not focused on algebra. There are very simple examples of word problems on the formula sheet with cost, distance, and simple interest. All of those are simple formulas that involve some simple substitution. Great place to introduce the concept of substitution. Here's a more complex example, whether or not a point lies on a line. Again, another classic GED problem. We'll say something like, does the point 2, 3 lie on the line y equals 5x minus 1? So in an example like that, you might be thinking, well, I'm don't teach that at all because that's that's slope and lines, and I almost never get to that with your class. No, but you always get to substitution. So if you have an advanced level student, somebody who is higher skilled, they could have a sheet full of problems like that while other people are working on the simpler examples of substitution. Graphing lines using a t-table is exactly the same thing. So I hope you guys know what I mean when I'm saying a t-table. It's when they say graph the line y equals 3x minus 1, and then they give them a table to fill in with some x values, and the y values are left blank. And so how do we find that? Well, we substitute in the x values to find the y values. So again, we have the GED loves slope and lines, by the way, you guys. If the GED has a favorite topic, it's slope and lines. And so you might say, I almost never get to that in my classroom because I don't have students who are advanced enough for it, or my whole class isn't ready for it. Well, again, while you're doing substitution, you do have students who are ready for it. Let them tackle substitution in this context. And you can see every single student, regardless of their level in the class, is going up in their GED score, going up in their proficiency, even though you're teaching a very basic skill. Okay. So do we really want students to understand substitution? How should we even broach the subject? I always, always, always recommend the best of both worlds. Anytime you're bringing up these big, overarching, important skills, you need to do some kind of exploration. If you want struggling students to finally pass math, we cannot stick to tips and tricks and the 3 easy steps for this and the 12 easy steps for that. Our students need to have a deep conceptual understanding. And so we need to do that exploratory learning. Now, of course, the argument against that is always it takes too long, right? It takes too long to do exploratory learning. And I agree with you that it takes a while to do exploratory learning, which is why you must choose wisely what we are going to explore. We need these big, giant concepts that apply all over. Well, guess what? Substitution is it. You want a big, giant concept that applies all over the areas of mathematics? That's it. And so this is a great time to do some exploration with your students so they really get it. Then from there, it is important to draw the connection to with directed instruction to exactly how you want them to apply it. So it's a real issue with struggling students that they don't make the leap between the exploratory activity and then what they actually need to do. And so that pattern recognition, especially in students with certain disabilities and other struggles, that pattern recognition is not necessarily there. So it is our job to make sure that pattern has become apparent to everybody. So I want that direct instruction as well. We're going to directly teach the logic of equivalence that forms the basis of why substitution is allowed. So why are we allowed to trade out equal things for each other? Well, that's the basis of logic that math is completely dependent on, right? We're gonna explicitly point out each time we have a new context. Look, there we go with substitution again. Aren't we just doing the exact same thing? I mean, how many of your students are overwhelmed? Your students are overwhelmed going, how am I ever going to remember all this? Whereas if we can come in and we can phrase it as, look at us just doing the exact same thing. It might look a little different, but this is exactly what we've been doing all along. It increases their memory. Now we are chunking information and we're grouping information, and they're going to be able to remember a lot more. And then I am just such a stickler for notation, you guys. Don't let students skip notation. Don't let them use incorrect notation that reveals a lack of understanding. It might not hurt them now. We tend to not stop them if they had a right answer. It's like, oh, they had a right answer, so why stop them? Because it can hurt them later. So it's important not only that they can get the right answers, but that they can communicate in the language of algebra. And substitution is huge in that. So as far as skipping notation or using incorrect notation, two big things for you, please, is that substitution is really one thing. Substitution should be it should go down. Like I said, anytime we replace something with something else, we're going to see it underneath. Okay, whether I'm simplifying or I am trading out a fraction for a decimal or anything, I want to see it directly underneath. Don't let students jump that equal sign like we were talking about. Okay, woo, woo, woo. Let's do something. Yeah, good. I've been talking for 30 minutes. You guys ready to participate? Okay, so these are in the packet that you guys have. You can get from the IPDA website, the handbook that goes along with this webinar. I have all these classroom things so that you can use them in your classroom. And this one is a question of the day. I use it like a bell work question. So students will come into the class and it'll already be up on the board. And the nice thing is this looks very scary to students, but if you read it, it's actually really simple. Even a level 1 student can accomplish this, and then they feel so excited when they do, because all they're really doing is matching letters to words that start with the same letter. And I got to tell you, I haven't even introduced formulas yet at this point. I haven't introduced physics. I haven't introduced algebra. Like, this is a day one and nobody struggles with it. And so it's great to attach that meaning to language. It's going to make that substitution come so much easier. So anyway, great example of using a leading question. Here's another example. We can get students to tell us what they need when it comes to substitution. So I might ask students, what is 8 times 5? And of course, they're like, oh, it's 40. What is 8 times 10? It's 80. And then I ask them, well, then what is 8 times a mystery number? X. And of course, they're like, people get stumped, right? We have different levels of ability in the class. So of course, some people are going to shoot out, Miss, it's 8X, which is true. It is 8X. But the point that I'm trying to get to with my students is not, is it 8X? It's like, what value is it though? And so I might probe them a little bit, like, okay, well, 8X, but how much is that? What's that worth? What's its value? And of course, rude, because that's a trick question. But again, every level of student, if I probe them and continue asking questions, can get to the point where they're like, I don't know. I can't tell you what 8 times X is. And I get to be like, why not? Why can't you tell me? And they're like, well, you didn't tell me X. X is a mystery. Bingo. I didn't tell you X. X is a mystery. And that's a perfect launch into, but what if I do tell you X? And so it's a real natural introduction to substitution. Another great way, another type of exploratory activity you can do with your students is to link it to concrete situations. Oh my gosh, I'm working with a woman right now, you guys, in her 60s, severe learning disabilities, thinks she's stupid because algebra is so hard for her, and she is so smart. As soon as I link it to the real world, she can do anything. And so, a lot of times that was all your students ever needed was a link to the real world. But a lot of times books do that really poorly, like they overcomplicate it. So make sure that it's simple here. So here's a great example of substitution of me doing right here. I'm buying lunch for myself and a coworker. I've got a coupon for $5 off the purchase of the 2 taco meals. How much is it going to cost me if I get 2 chicken taco meals? How about if I get 2 steak taco meals, which are more expensive? This is substitution, right? We have a expression up there. It's in words, not in symbols. And we're plugging in different values to see what happens. How about if I buy shrimp taco meals? And then you can have the students from there try to write expressions. Obviously, this one is appropriate for students who have some experience writing expressions, but great example. And then we can use that expression instead of the usual arithmetic way to find another value. All right, let's play a game. So this is another way that you can introduce it. I love playing in or out. In or out is a great game to play. So here's the rules. I have some points on this one that are in. So obviously, if I was doing with the class, they would have already been introduced to the concept of points. And then I have some points that are out. And your goal is to just try to tell me another point that's in. And I love playing this game right now with students who are multi-level, because even if a student gets it, I can be like, tell me some in points, tell me some out points to help your classmates so people can keep playing along. So it's really nice. Nobody just shouts out the right answer. So anyway, your turn, guys. Take a look at these in and out points. I will actually shut up for a minute, sip my water, and tell me, just guess, what are some points you think are in or out? And I'll tell you if they work. Kim, I don't see your first number. Ooh, 40 is out. I'm gonna put it here. But I like 10-4. Nice job. That's a 10-4, good buddy. 10-4 is in. 60. I'm sorry. 60 is out. So, Christopher, you got one that was in. So, if you were my student, I would say, okay, you got one that's in. Can you give me another example of one that's in? Can you give me an example of one that's out? 24-11. I love it. That is definitely in. Ooh, I'm sorry. 3-8 is out. Although I think you might have the right idea and be a little mixed up. Oh man. You know, 24-10 is out, but 24-11 is in. Oh yeah, 24-11 is already there. 18-10 is absolutely. Oh, I like that example, Christopher. 18-10 is out. Nice job, Dave. 8-3 is in. Now, if I was playing this with my students, I might go as long as 5 minutes. It depends how fast. I would read the room. With you guys, we don't have a ton of time today, so I think I'm going to call this good, although I will say to Shay, yes, or Aaron, absolutely, 38-18 is in. And so the rule here, basically, guys, is that you double the X and then subtract 1 if you didn't figure it out. I would do this a lot longer with my students, but I'm going to move on today. So this is a fun game where we're mentally doing substitution over and over again. We're trying to find out a pattern, and we can see there with that how it relates to substitution. All right. Nice job, you guys. I did include the rules for this in the PowerPoint. They're also in the handbook, so you can play it with your students. You can use a simpler point. Instead of doing 2x plus 1 or 2x minus 1, you could do something simple like just 3x. Depends on the level of your class. Read the room. I know you guys do. Okay. Now, there is a debate. I showed you how to do substitution in the TI-30XS calculator, the GED calculator. But I also teach substitution by hand. In fact, teaching substitution by hand is one of the most important skills you can teach your students. So a lot of times, if they can do it in the calculator, I don't even have them do it by hand. Like adding and subtracting fractions, I don't teach. I let my students do it in the calculator. Why? Because it's not super crucial to the world of algebra to be able to add and subtract fractions by hand. But you know what is super crucial? Substitution. So there's advantages to teaching them to do it by hand, where they actually have to show their work. It builds that foundational skill of symbolic fluency, which we really, really need. This is the best place to do it. And they do need to be able to solve multi-step equations on the GED, which means they need to be super, super, super fluent at replacing one thing with something equivalent, replacing one thing with something equivalent, and so on and so forth. It develops that foundational skill of maintaining equivalence to form a logical argument. That is literally all mathematics is keeping things equal, like I already said. In fact, I have a whole presentation on just how, if you really want struggling students to understand, teach them to value the equal sign. Like I can talk about that for an hour, you guys. So that idea of maintaining equivalence is so important. And then it's a crucial skill for college readiness. Do you want your students to believe they can succeed in college algebra? Then they better be able to do substitution by hand. And of course, it increases student confidence because they feel so cool because they're doing the hard stuff, right? Oh, algebra is the hard stuff. Okay, now substitution in the TI-30XS. Why do we want to teach that as well then? Why do we care? Well, we have a serious issue with students' transcription errors. We already talked about that. If they have any kind of a struggle with understanding a certain type of number, which happens with fractions, happens with negatives, happens with exponents, they are going to drop them. They're going to transcribe them wrong very frequently, much more frequently than they would other kinds of numbers. And so that happens, that's less likely to happen with the calculator there. And it avoids that most common evaluation error, the one that I told you about, which is plugging negatives into exponential equations. Oh, they almost always forget the parentheses, always. Like I've had teachers argue with me who didn't know that. So they don't even have to remember to use parentheses. And of course, just knowing how to use that in the calculator reduces that test taking anxiety a lot. And anxiety is often what's holding a lot of our students back. It's not even the skills. And then, of course, saving time while they're test taking. We have students who run out of time. So for all those reasons, I highly recommend you teach it both ways. I'll have my students practice their substitution by hand, check their work in a calculator. Okay, where are we at? Oh, you guys, we're doing so good on time. I'm famous for going overtime, but I think we're going to be perfect. Hey, winning at life today. Okay, so applications everywhere. Just really quickly, I'll go through different ways you can teach this to different levels. So, but before I do, I just want to say how I do it. I don't do a day where I teach a little skill that applies at one level. I teach these big overarching skills like utilizing formulas or evaluating expressions. Both of those involve substitution, right? And then I'll have 3 to 4 levels of practice so that every level student can practice the same skill, but at their level. And so that's the idea here. Not that you break it up. One day's a beginner day, one day's an experience day, one day's an advanced day, but that you teach a big overarching concept and then you have practice for at every level for every student, especially if you can't have a divided classroom like most adult educators. So beginning level examples of substitution, like we said, converting numbers. I already said that one. We talked about simplifying expressions with the order of operations. Some of this is just review, huh? Converting to equivalent expressions. So on the GED, it might say which expression below is equivalent to, and it'll probably be a number property like, oh, I'll do it with numbers for a beginner. 5 times 7 plus 3. And then you'll see in the multiple choices, there's 5 times 7 plus 3, 5 times 7 plus 5 times 3. This is just an application of the distributive property, but you can see the idea here. They're not simplifying, they're finding equivalent expressions. Oh, subtract. Oh, great examples of other ones that we use all the time. So a lot of times you guys will say like, have memory tricks for certain things we do in basic math. I had a teacher tell me the other day when they were doing something like 5 minus -5, they said, what did they say? Leave, change, change. Leave, change, change. Like you can change the negative to a positive, turn the minus to addition. But the idea here is that's an act of substitution, right? Subtracting a negative is the same as adding a positive. So we've just traded two things out. It's not that this is really addition, it's that we have done substitution. We've traded this out for something equal that's easier for us to handle. And then, yeah, Kim, the next one is the one that people will say keep, change, flip. But it's the same idea. It's something equivalent. Dividing by a fraction is the same as multiplying by its reciprocal. I've traded out two equivalent things. Students really need to understand it as that. Like keep, change, change is a nice memory phrase. Keep, change, flip is a nice memory phrase, but it absolutely has to be paired to the understanding that they are trading out equivalent expressions. All right. That's my lecture. Thank you for coming to my TED Talk. I'll do a TED Talk one day, you guys, maybe. Okay. So yeah, subtracting a negative, dividing by a fraction. Oh, turning repeated addition into multiplication. Like adding 5 repeatedly. 5 plus 5 plus 5 is the same as 5 times 4. Or similarly, turning repeated multiplication into a exponential expression. Those are both acts of substitution. Kim's coming to my TED Talk. Thanks, Kim. Thanks for supporting. All right. Yeah, using those simple formulas. I highly recommend you use those very simple area and perimeter formulas or science formulas with your beginning level students right from the start. They'll be doing algebra right from the start. They can totally handle it, and the confidence building is crazy. So distance, cost, simple interests are nice, those physics formulas and those simple geometry formulas. And then, of course, evaluating expressions with just one variable, one letter in them. Simpler expressions, any student at a beginner level can handle that. Even how you will have students insert invisible ones. You guys do this all the time. Let me take off the x squared and let me just do x. If you're doing x plus 2x, you know your students have a lot of trouble with that. And sometimes people will say, just put a 1 in front. If you don't see a number in front, it's a 1. Why is that legal? Well, it's an act of substitution. X and 1x are the same thing. So I'm not simplifying, obviously, in that case. I'm making it more complicated. But since those two things are equivalent, I can totally do it. 53. Okay, I'm going to go faster, you guys. Okay, so some experience level examples obviously are simplifying algebraic expressions, whether I'm adding and subtracting like terms or I'm multiplying and dividing binomials, converting to equivalent algebraic expressions, so using like the exponent rules, the distributive property. Solving geometry formulas. Now, this time you're solving them when you plug in, like say you know the area, but you have to solve for the width. That's a more complex skill. And usually my beginners need a little more support before they're ready for that. Working with more complex formulas, think of the Pythagorean theorem. It's going to be a more experienced level student who's substituting into that. Same thing with the slope formula or quadratic equations. So, you could have taught substitution one day and some of your students are doing slope. Graphing lines with t-tables, evaluating expressions and multivariables, or with negative numbers, or with function notation. Those are all great examples for an experienced level student. And then for an advanced level student, factoring. More complex applications of those geometry formulas. For example, when you have to solve for radius, when you have volume of a cylinder, that's a tricky one for students. Any of the volume formulas that have the capital B for base in there. The quadratic formula with irrational or imaginary solutions. That one's tricky. Solving systems of equations uses substitution, writing equations of lines. Beautiful. Okay. So, woo, ooh, I have a minute to recap. You guys, ooh, I win today. Okay, so recap what we learned today. The act of substitution, it's foundational, you guys. I can't think of a more foundational skill. We use it every day. It shows up in dozens of GED applications and it's crucial to college algebra, so it is a good, valuable place to focus your time. The students need to learn it both by hand and in the calculator. I recommend you do it both ways. And if your students object, you explain why, because I want you to be able to have any career you want. I don't want to limit you. So I want to make sure you could be successful in college and on this test. And you can totally tailor your introduction to substitution to the focus of your unit. You have a lot of options. But when you do it, make sure that you allow for exploration and direct instruction. And yeah, we've got it across the curriculum so students can practice at any level. Amber, the slides and the handout that has all the goodies will be available on the IPDAY website. And so that's what I'm here to tell you now. Last thing I need to tell you is that all the resources from today, all the tools from today will be in the handout on the website within, I think it's 48 hours that they have it posted within. But I've got all kinds of goodies for you in there. And there's the goodies I have for you. And now it's time to give IPDAY your feedback. All right, you guys, keep me in a job. Tell them how much you adore me. But while you're doing that, I'll let you know this is a 3-part series, right? I'm doing 3 of them. So the next essential algebra skill is fun. It is simplifying, and we are going to talk about that Wednesday, March 4th. We're taking a week off because I am going to Florida. Hopefully I see some of you next week at workshops. But the week after that, March 4th, we will be talking essential algebra skill 2. So I hope you'll join me then. All right, you guys. Thanks.